Hello students, welcome to Showed Up Sir classes, and in this particular video we will be solving the question from AP Calculus of this AB exam paper. Okay, so we are solving the question from part A. So where there are 30 questions, our time duration is 1 hour. So let's move to this question number 60. So here it is given, that if dy dx is equal to 2 minus y, and if y equal to 1, x equal to 1, then we have to find the value of y. So first, what is the topic is about? So this is all about this finding general solutions using separation of variables, right? So this is the topic. So now we have to solve this problem. So the differential equation, this differential equation can be always solved from the separation of variables and the initial condition to determine the appropriate value for the arbitrary constant. So here we have been given this dy dx is equal to 2 minus y. So which we should be, the solved should be the separation of variables, and the initial conditions are given, that is x equal to 1 and x equal to 1. When is x equal to 1? When y is equal to 1, right? So you can just in this manner, that if is y equal to 1, then only x is equal to 1. So from here we can, so this is the differential equation. So from here we can write in this manner, this dy by 2 minus y equal to dx, right? If we do the differentiation in both sides, so this integration on both sides, so 1 by 2 minus y dy equal to integration of dx. So this is nothing but minus of ln mod 2 minus y equal to x plus c. So if we put the value of y equal to 1 and the x equal to 1, the initial conditions, so we will have this minus of ln value 1, 2 minus 1, 1, 1 plus c. So c will have this value as minus 1. Now put the value of c over here, so that we can rewrite this equation as minus of ln mod 2 minus y equal to x minus 1, right? Or we can write this ln mod of 2 minus y is equal to minus x plus 1, or mod of 2 minus y e to the power 1 minus x, right? So we can write it in this form. Since this, you can see that 2 minus y, this is always greater than 0, and initial value y is 1 equal to, is y equal to 1 given. So the solution to the differential equation, it is 2 minus y equal to e to the power 1 minus x, or we can write y equal to 2 minus e to the power 1 minus x. Okay. This we can write. So let's check with the correct option. So the correct option for 16 is B, where you can see that 2 minus e to the power 1 minus x. So this is the value of y. So question number 17 is saying that let g be the function given by this gx integration of 3 to x t square minus 5t minus 14 dt. So we have to find what is the x coordinate of the point of inflection of the graph of g. So the topic name from where it belongs is we have to interpreting the behavior, okay, of accumulation function involving area, right? So to find for this question, so we have to find the point of inflection. So to find the point of inflection of the graph of g, so we have to determine where g double prime changes its sign, right? So here we have this g of prime x is given as x square minus 5x minus 14. So if we do this double differentiation g of double prime x, it will be 2x minus 5, right? So g of double prime x is equal to 0, which states that at x equal to 5 by 2, this g of double prime x is equal to 0 at this value of 5 by 2. Then since this g double prime of x is less than 0 for x less than 5 by 2, and we have this, and for, okay, so and g double prime of x, it will be greater than 0 for x greater than 5 by 2, right? So the graph of the g is, from here we can infer that this graph of g changes concavity at x equal to 5 by 2. So therefore the point of inflection will be this graph g has a point of inflection at x equal to 5 by 2. So if we check with the correct option, so this is 17b, that is 5 by 2. So in the question number 18, you can see we have to find the derivative of this trigonometric function. So this topic is a combination of the both product rule and chain rule, right? So this combination of the product rule and the chain rule is used to compute this derivative. So we have been given this d dx of x cube sec of 2x, okay? So if we do the derivative, first it will be x cube over here, then we have d dx of sec of 2x sec of 2x plus, we can do this derivative 3 of x square sec of 2x, right? Then we can write this in this manner again, so it will be x cube simply, then we have sec of 2x multiplied by tan of 2x multiplied by 2 for this 2x plus 3x square sec of 2x, right? So if we simplify this, it will be 2x cube sec of 2x tan of 2x plus 3x square sec of 2x. So this will be the expression. So this will be the value of the derivative. So if we check with this function, we check with the option. So this option D is correct for question number 18. So 2x x cube sec 2x tan 2x plus 3x square sec 2x. So this question number 19. It is given that a particle moves along the y-axis so that at time t greater than equal to 0 its position is given by yt equal to t cube minus 4t square plus 4t plus 3. So which of the following statements describes the motion of the particle at time t equal to 1? So the topic of this particular sum is simply this straight line motion and measuring this position, velocity and acceleration, right? So this question can be solved easily. So here it is given that the position is given by y of t. It is nothing but t cube minus 4t square plus 4t plus 3. So the velocity of the particle which is v of t, it is given by vt, it will be 3t square minus 8t plus 4, right? Now at time this t equal to 1 it is given, so v of 1 will be minus 1. From here you can get, since the velocity here is negative, so we can say that the particle is moving down the y-axis, right? So the particle is moving down the y-axis. From here you can see. So if we find the rate of this change of velocity, that is of this function of this particular velocity, the rate of change of velocity will be, rate of change of velocity is nothing but acceleration, or you can say it is deceleration if it's negative. So rate of change of velocity is nothing but v prime t, so it will be 6t minus of 8. Similarly at time t1, so if we want to find the rate of change of velocity, so at time t equal to 1 we have this v of prime 1 equal to minus 2, right? So since this is also negative, so from here we can say that the particle, so you can say it is negative, so the particle is moving with decreasing velocity, is moving with decreasing velocity at time t equal to 1. Okay, so the correct option here is A only, that is particle is moving down the y-axis. So from here we can find that the particle is moving down the y-axis, and from the rate of change of velocity with decreasing velocity we can get. So this correct option for question number 19 is A. Question number 20 is saying that if the integral from 1 to 4 f of x gx is equal to 8 and integral 1 to 4 gx dx is equal to minus 2, then which of the following cannot be determined from the information given? So from this is topic of the applying properties of definite integrals. So the applying properties of definite integrals. Okay, so we can definite integrals. Yeah. So how to solve? So if we take this option, consider the option A, integral 4 to 1 gx. So this is incorrect because the value of this integral can be determined using this property of the definite integral, right? So from here, this if we take this option A, let us take this. So this integral 4 to 1 gx dx, right? So we can write it as integral of so it put it minus over here, so 1, so minus 4 this g of x dx, so it is nothing but minus minus of 2 2, so that value we can determine. Similarly, from this b we can also determine the value of the b. It will come at about 24. So if we consider the option C, so in option C we have this integral of 1 to 4 3 of fx gx dx, right? So this is given. So this is in general case, this is not true. This is not equal to this 1 by 4 3 of fx dx multiplied by integral dx multiplied by integral 1 by 4 gx dx, right? So the individual values of this particular function, that this integral of 1 by 4 fx dx and integral of 1 by 4 gx dx, the individual values of this particular function, these two functions, this cannot be used to determine the value of this function, right? So the individual values, these individual values can be used to determine the value of this function. It is true. So suppose you can take that, for example, if f of x is given as 8 by 3 and g of x is coming out as minus 2 by 3, so then we have this integral 1 by 4 or 1 to 4 integral f of x dx, it will be equal to 8, and so this will be equal to 8, and integral of 1 to 4 g of x dx, it is equal to 2, is nothing but minus 2, sorry. And if we want to find this value of 1 to 4 3 of fx gx dx, so what will be this value? So it will be integral 1 to 4 minus of 16 by 3 dx, which is nothing but minus 16, right? However, if this f of x is equal to 16 by 9 x minus 1 and this gx is equal to minus of 4 by 9 x minus 1, right? Then integral 1 to 4 f of x dx is equal to 8, and this integral of 1 to 4 gx dx is equal to minus 2 as before. But now this will be, what will be the value of this? So if we write this value will be 1 by 4 3 of fx gx dx, right? So we can put the value of 1 by 4 up to this point, and it is minus 64 by 27 which is nothing but this x minus 1 whole square dx. So which is equal to, if we solve this, it will be equal to minus 64 by 3, right? So these two values are entirely different from this value. So we can conclude that the individual values of this particular two integrals, it cannot be given in this form, cannot be used to determine the value of this particular integral. So in our case, the correct option for question number 20 is C, that is integral of 1 to 4 3 of fx gx dx.